Okay, so what we're dealing with here is linear inequalities, okay? So that's greater than or less than, okay? So remember this. Less than's always this way. Negatives are increasing, positive, it's going up, correct? So your symbols, facing this direction, greater than, this one less than. You have two vocabulary words. Looking at the first example, what we're doing is substitution. Okay, we're taking an ordered pair, the x and y, we're plugging it in here, and we're seeing whether it's true or not. Okay, so we have 7 and 3. There's our x, there's our y. So x and y, solve for it. 7 minus 1, 6, bring down 3. Now, inequalities. It doesn't mean the numbers are equal. Okay? You want to say this to yourself. Is 3 less than 6? Well, it is, right? And you need to put it on a number line. 3 facing this direction, 3 is less than 6. Any questions? Okay, so let's look at the next one. We have an ordered pair. This is in linear format, right? So we draw a line and we replace our x and our y. So our y is 5 and our x is 3. Then we go ahead and solve for it. 3 times 4 is 12. Bring down the 2, bring down the 5. 12 plus 2 is 14. Bring down the 5. Then read it. 5 is greater than 14. Is that true? Is 5 greater than 14? No. So this one is not a true statement. Now, what we're trying to do, you're going to see when we get further into graphing, we're seeing if this ordered pair is within this solution. Is it in the shaded area? Could it be a possible solution for a linear inequality? Okay? So,
no.
Any questions on these two? I'm recording right now.
Oh, okay. No, it's because like,
No. Okay, C. Going to C. First of all, any questions on this? We know our x, we know our y. We plug it in and we solve for it, right? Next one. Y less than 3x plus 4. Okay. Now, when we don't have an ordered pair, we use 0, 0 as our pair, which is origin, right? So we're going to do the same thing here. We're going to call the y 0, and we're going to call the x 0, and we're going to see with this type of substitution whether it's true or not. So 3 times 0 is 0, bring down the 4, then we have 0 is less than 4. Well, is that true? Yeah, because on our number line, 4 and 0, it's less than, it's going this direction. So yes. So don't have an ordered pair, what do? What ordered pair do you use? I just told you. 0 and 0. Okay? When you don't have an ordered pair, plug in 0, 0 for y and 0 for x. Okay? Alright, let's talk about this one for a minute. When you go to substitute the 0 and 0, and we go to graph this out, so this is in this linear format, right? So our b is 4, but we're starting at 0. Okay, 0, 0. We're looking at this ordered pair of 4 with a rise and run of 3 over 1. Okay? Well, this is what's key here. When you have something like this, when it's saying less than or greater than, it's a dashed line. Okay? If there's a line underneath it, it's greater than or equal to, it's a solid line. Okay? So, I'm going to go graph this out. Okay? I'm going to start at 4. I'm going to go up 3 and over 1, and that's going to be my line. So what we're trying to solve is that 0 a 0 that we plugged in for here? Is it a solution? Daisy, stay with me. This line is shading it down because it's less than, so less than always goes down. And the way you can remember that is the graph is increasing going up, right? So going down would be less than. So we shade this area. Ultimately, us putting this solution in, we're trying to see if it's in the shaded area. So when we go to graph this out at the 4, and then doing a 3 over 1, and we put this dashed line in, and we shade down, 0, 0 is within this area. So this is a solution that works within the shaded area. Make sense? Yes? No? Okay. Alright, next one. 3x plus 2y equals 6. Or excuse me, is greater than or equal to 6. We have to get this in slope form first. Okay, so this is y equals mx plus b, right? So, you guys know how to do this now. You treat this like the equal sign when we're going to solve this. Subtract 3x from both sides, negative 3x plus 2. Divide the 2 to get the y by itself. That leaves us a fraction, negative 3 over 2. We don't have to simplify that because it's a rise and run. 6 over 2, 3. So now this is linear, right? So now what we're going to do is we're going to plug this information in, the 0, 0, because we don't have an ordered pair, and we're going to see if it's a solution. So we're going to write our equation, draw a line underneath it. We're going to put a 0 in here, and we're going to put a 0 in for x. Well, lucky for us, this fraction by 0, nothing, right? It's just 0. Bring down the 3, bring down the 0. Then read this to yourself. 0 is greater than or equal to 3. Well, that's not true, right? 0 can't be greater than 3. Now, when we go to graph this out, this is on our slope form. We go to 3, okay? We go down 3 and over 2. There's our line, right? Well, it's greater than, so it shades up. It's equal to, it's a solid line, and our 0, 0 is in there. It's not within that shaded area. Are we following what we're doing here? So when you don't have an ordered pair, you're using 0, 0. You're getting in slope form. You're graphing it out. If it's equal to, less than or equal to, greater than or equal to, it's a solid line. If it's just greater than or equal to, it's a dashed line. And once again, if it's less than, shaded down. If it's greater than, shaded up. Are we clear? Okay, look at this next one. It's already in slope form. We just need to go graph it out. Where 2, our rise and run is down 1 and over 3. This is less than, so it's going to be a dashed line shaded down. Okay? All we had to do was take this line, graph it out. We're doing whether it's a dashed line or it's a solid line, and then shading the direction that goes. Okay, so these ones are easier. So looking at this one, we got to take care of the minus 2. So plus times minus 2 turns at minus 2. Then we can graph this out. So we start on the 2. We go up 5 and over 1. There's our line. It's a solid line because it's equal to. It's also greater than, so it's going to shade up. Good? Thumbs up, down, somewhat. All you have to remember is, you guys know how to graph, right? Graph it out. If it's greater than, it's being shaded up. Okay? If it's less than, it's being shaded down. If there's that little line that's underneath there, it's a solid line. If there's no line, it's dashed. Okay? This one right here, this one's kind of tricky. It says y equals none. So it has no slope. Okay? Then it's telling us x is greater than or equal to negative 2. So when we go to graph this out, our x is going to be negative 2. There's going to be no slope. It's going to go straight up and down. And it's going to be greater than, so it's going to be shaded this direction. Okay? That's it. That's all that's involved here. So you guys know how to get things in slope form. When you have an ordered pair, you plug in that ordered pair, and you're seeing whether it's true or not. Okay? The second part is, if you have something in linear form, and you don't have an ordered pair, you're plugging in 0, 0, and you're solving to see whether it's a solution. Okay? How you know it's a solution is ultimately the statement is true in the end, or you can see it on the graph and you go to graph it out and shade it. Okay? Less than, shade it down. Greater than, shade it up. Solid line, greater than or equal to. Dash line, it's just an inequality. Greater than or less than. Okay? So what I want you guys to do, you have an ordered pair. You have something that's linear. You're going to draw a line. You're going to replace your x and y. You're going to solve and see whether it's true, and then you're going to graph it out. When you go to graph it out, once again, this one's going to have a dashed line. This one's less than. It's going down. This one's greater than. It's going to be solid line. It's going to be shaded up. This one's less than or equal to solid line shaded down. This one's greater than shaded up dashed line. Go and put the ordered pairs. Put just like here, how we did this one. We have this linear. I went and graphed it out, and I put 0, 0 in there. 0, 0 was a solution. Nice thing is you're not doing 0, 0 on these ones. You have these ordered pairs. You're seeing these ordered pairs are fit within that shaded area. Okay? And that's it. So kind of a new concept, right? Dash line greater than or equal to, solid line, less than or equal to by itself is a dash line. Shade down for less than, shade up for greater than. Okay? Okay?